welcome everybody. Welcome to the Raspberry Pi Foundation seminar. We've had a little bit of a break, but we're back now. And also we've got 3 in a row. So we've got one this week, a panel next week, and a seminar after that. So we're back with a vengeance. Delighted that we're going to be hearing from Maya Israel in today's session. And thank you all for joining us. This is part of our series of obviously computing education research seminars. This particular series from January to July is all focused on diversity and inclusion in a variety of different ways. And we've put this on because this is very important to the foundation and a lot of you as well. And we're partnering in this venture with the Royal Academy of Engineering, who are also very involved in this area. And our objectives are, so firstly, so that we can ensure that that the materials that we produce as the foundation allow our learners to see themselves represented, to enable them to represent themselves, and to enable people to feel included and to have all the opportunities that they can have in computing education. And as part of this was running these seminars, and we do want everybody to be able to enjoy the seminar and to hear from the speaker and from each other in the breakout group. And our only ground rule in a way is that everybody's willing to listen to other points of view, to be able to speak freely and learn something from other people. And now I'd like to introduce Maya Israel. She's from the University of Florida, where apparently it's very warm, warmer probably than Cambridge. And she's going to be speaking to us about making computer science teaching inclusive through universal design for learning.
Okay, thank you so much for inviting me to be here. Let me put this into present mode. So what I'd like to do today is talk to you about how myself and the folks who work with me at the University of Florida at the Creative Technology Research Lab are thinking about access and inclusion from a universal design for learning in computer science education. So I'm going to start off by giving you just kind of a brief overview of our approach to doing this, and then I'm going to walk through, I think, 3 or 4 studies to give you a sense of the kind of work that we do. And I just started my timer because I'm very time conscious. And if you are tweeting, you can use my Twitter handle, which is just misrael09 as well. So the primary goal that I think about is how to increase access to computer science education, primarily for students with disabilities and other students who typically aren't finding a lot of success, both generally in academics and in computer science education. My background is not in computer science. I was a special education teacher. I got my doctorate in special education. And I focused a lot on how do we engage and include students with disabilities. And when I first started this work, I was looking at actually video games and getting children involved in academic content through learning through video games. And somewhere around 2010, maybe, we started to do some participatory design work with students with disabilities in terms of how do you design technology that would support your own learning. And I had this real epiphany about how students can be engaged in the design process and in computer science. So my shift really turned from designing tech for children to helping students learn how to design technology for themselves. So that's the place that I came from. And so I came to computer science and learning about computer science from that perspective. So that's just the framing that I come to this. This slide just presents different programs that we have, and I'll highlight some of these throughout the talk. Time for CS is a project with Broward County Public Schools. It's a big school district here in Florida, where we're integrating computational thinking and computer science for into science instruction in particular, but we're designing that with a universal design for learning perspective, but also a culturally responsive and sustaining pedagogy. So that particular project is about, can we design materials in a way that are baked with these constructs from the very beginning in a way that helps teachers use those. I've got the University, Michigan State University up there. We've got a project with them where we're teaching pre-service special education teachers how to integrate computational thinking into both content that they're responsible for, such as math, and also as they're thinking about technology and assistive technology, how do they consider computer science in that realm? In fact, is a large consortium of researchers working together looking at self-efficacy, self-regulation. How do we think about designing instruction with scaffolds and computational thinking activities that are scaffolded in order to support that self-regulation and the metacognition. UDL for CS is a research practice partnership where we have collaborated with school districts and states around this problem of practice related to what extent are students with disabilities actually included in computer science education. What kind of data do we have? How can we move the needle, the inclusion needle, towards more access and inclusion? And LTech is a project where we're integrating computational thinking into math. And just like with Time for CS, we're looking at it from a universal design for learning perspective. So we look at, we've got project in pre-service education, we've got project looking at professional development, and we also have projects that are focused on design and development. So along that entire continuum. And so when I think about that continuum, one of the first things I come to is this idea that all children that we work with, including ourselves, have what we call a jagged learning profile. And so the idea is that there aren't these buckets of children and adults that fall into like these categories, like a low achieving category or a high achieving category. We all have this very jagged learning profile where there are some things that we have strengths in and some things that we struggle in. And so for every person that we meet, their profile is going to look a little bit different. And so when we think about designing, doing so for the average, that middle category essentially means that we're not really designing for anyone. And so that mindset makes me think that we need to be much more flexible in the design of curriculum, in the design of tools, in the design of professional development, and of lesson plans. And so that's really where universal design for learning comes from, is assuming that we all, like this variability amongst us means that we cannot really think about the average learner. We want to think about the range of learners that we are meeting. So I wanted to just add a little bit of statistics here, because here in the United States, we know that about 7.5 million children with disabilities are receiving special education services. And those, the primary, is the largest category of students receiving special education services here are students with learning disabilities. So those are about 35% of students. The next kind of larger categories are students who have speech and language needs, other health needs, and autism. And the majority of these learners, what's important to know is that they're taught alongside their peers in regular classrooms. So the assumption is that if we're going to teach computer science, students with disabilities are going to be in there along with their peers. So their jagged learning profiles are included alongside everybody else's. And so it's really important to think about their needs as part of the larger discourse of access and inclusion. So the beginning of this journey started with trying to understand the barriers to inclusion. And so we spent many years looking to see what's happening. I guess we call it CS in the wild, to see how are different students actually being taught. And I'll start off by saying that teachers want to do the right thing for their learners, but what we found is that many of them just didn't know how to apply some of the best practices in computer science education. So they were oftentimes new to computer science. And so even if they had some of these really good teaching practices that they used in other content areas, knowing how to apply them in computer science was a real challenge for them. So we take this systems approach. So if you think about the outcome being limited inclusion, there are multiple things that result in that. So everything from barriers in the classroom, such as, the teacher not knowing about the instructional technologies that are available to them and pedagogical approaches, to school level barriers such as scheduling, frankly. So when is computer science taught? Is it taught at the same time as maybe other classes that students with learning needs had to take? And so they were in conflict, to the more systemic barriers, such as the curriculum not being accessible, not having the tools that are available. And so, and like the district level or state level policies that might actually limit inclusion. So we really do take a systems approach to examining some of those barriers. This is actually hot off the presses. And so without mentioning a particular school district, what we did is that we looked at students with disabilities compared to students without disabilities at the elementary, at the middle, and at the high school level, and their level of inclusion. And so what we did in this particular study is looked at who was included in those computer science opportunities at the elementary, at the middle, and the high school level by disability category. And we saw some interesting trends. The first trend that we saw mimicked kind of the general trend, which is in this particular district, there was a CS4All initiative. So at the elementary level, kids generally had some exposure to computer science. At the middle school level, when it was time to choose computer science, fewer people took computer science. And at the high school level, where it was an elective that was competing against a lot of things, even fewer students. So that trend is kind of mirrors the trend in the general student population. But when we started to disaggregate the data by disability categorization, we saw some really interesting findings. For example, at the elementary level, by disability category, it's pretty similar. Students across disability, about 20% of students, about a quarter of students with disabilities had access to computer science education. At the middle school level, except for students with autism, there was a pretty steep decline into the teens. 13% of students with emotional disturbance were receiving computer science education. 15% of students with learning disabilities, 16% of students with health impairments, and 15% of students who had speech and language needs. And then at the high school level, there was even a sharper drop. So looking at particularly at students with learning disabilities in this particular district, this is a large district, so we're talking about almost 60,000 students. Only 6% of students with learning disabilities had access to computer science education. What's important to note is that students with learning disabilities have kind of many of the disability categories, these are students who really do very well with a few accommodations. And so these are the students who often need extended time to take exams, might need some additional accommodations, but they're usually taught in the same content as their peers. And so there's really no reason why only 6% of students at the high school level with LD are receiving computer science education. The trend is a little bit different with autism, which we need to unpack even further, where there's an increase at the middle school level, and there's still a decrease at the high school level, but not as steep as some of the other categories as well. And the reason that I'm showing this is that one of the things I hope folks come out of this is how important it is to disaggregate the data. That, looking at averages makes our ability to tell whether our computer science activities are meeting the needs of all students kind of wash out in those averages. And so it's really important to do so. Our next kind of pass with this data is to look at developing a multi-level model where we also look at other level 1 variables such as socioeconomics, cultural background, even like, and then level 2. So the level 1 headings are in like the student themselves. So their demographics, their backgrounds, and then level 2 are like the classroom environment. So are these trends going to be the same in schools that have more access to technology and computer science? So if there are a lot of offerings, are we going to see the same? And then also at the high school level, what computer science classes are students with disabilities taking? For example, are they taking the AP computer science classes versus the other ones as well? So we have a lot more work to unpack this data. But what's important to know is that it's really important to do that unpacking. So the student level barriers that we often see, I kind of like to compare this to reading. So decoding and comprehending the text, not having those metacognitive strategies to do so unless they're explicitly taught to the students. So it's very important to address the fact that they might really have a difficult time decoding the text and comprehending it as a complete package. Multi-level complex problem solving is a real challenge for students who, many students with disabilities. So how do they debug a problem when they come across one? How do they strategically plan a project from beginning to end and follow those steps? And it often leads to a lot of frustration and task abandonment. And so in a moment when we transition from barriers to pathways, we spend a lot of time teaching metacognitive strategies, self-regulation strategies, and kind of like thinking about your own thinking, which is really important in addressing these particular barriers. From a tool and curriculum perspective, there are a lot of barriers because there's no such thing as a fully accessible programming platform. What's accessible to one population of learners is not going to be accessible to another population of learners. And so, for example, we use a lot of block-based programming languages, which are really wonderful for students who, many students with learning disabilities, because some of the syntax that they get lost in, they don't have to worry about when they're moving blocks of code around. But those programming languages are inaccessible to students who have low vision or who are blind. And so this idea of what makes a program or a tool accessible is really complicated. Another accessibility barrier is that many of the cognitive supports aren't built into these systems, so we have to layer them on top of the tools in terms of those teaching strategies. And often these very open-ended activities have limited structure. And so for students who struggle with complex multi-step problems, layering that structure on top as a scaffold and then slowly taking that away as students are learning those strategies on their own is something that isn't typically built into curricula and tools. So I'm going to just share a little video. It's called It's Glitching. If we can't hear it, I'll have to stop sharing and reshare because I don't know if I have the audio. So you'll have to tell me.
What's the matter? It's glitching. It keeps on glitching. Stop. What do you have for your code? That so far. Okay. For the rain. Let me see if that's the same code I have. No, for the rain. It's because I'm trying to make rain sounds. That's too many rain sounds. Just letting you know. That's too many. And the computers. What will happen if you put too many? It will kind of glitch. I think. No, because I wish my dad was here. It's not working because it's glitched.
So this is an example of we do a lot of video screen capture and we see what happens with students. This is a pretty typical example of a child who's trying to make rain sounds on this penguin, and clearly there's a problem here. And you probably can't see it very clearly, but the student put a lot of different sound blocks inside this repeat block. And so everything is happening at the same time, and it just sounds like a hot mess. And they can't figure out what's going on. And so this is an example of like just knowing what they want to do, articulating what they want to do, but really not being able to figuring out what the problem. And so these kinds of videos are fantastic, and we do a lot of coding of this to see what the issue is. Let's see. Whoop, sorry. So that kind of like gets to the problem. I had a professor in grad school that says that we need to move beyond admiring the problem, but I think it's really important to understand the problem. So this is kind of that transition to pathways towards inclusion. And so just like we do with understanding barriers, we take a systems approach to understanding how do we move towards fuller participation. What can we do in terms of the classroom? And that's where we really think about universal design for learning at the school level in terms of the systems for scheduling, for making sure that there are assistive technologies, that there are curricula that the teachers have access to, and at the systems level where we have like policies around computer science for all and like professional development that includes special education teachers alongside computer science education teachers. And so we study these within kind of the systems approach. So what UDL does, just as a quick either reminder or introduction, is like we've talked about this jagged profile and talked about the fact that we need to have more flexible instruction. And so what we start with is we think about what are the barriers within the learning environment, the barriers in the classroom, the barriers in the tools, the barriers in the curriculum, the barriers in our knowledge, the barriers related to our biases. And then we think taking that and then acknowledging that variability is the norm and that we have these jagged learning profiles. And then we'd go to the universal design for learning principle. So there are these 3 principles around engagement, representation, and action and expression. And I'll have a slide that shows a link to this. But the idea is like, how can we engage children in multiple ways so that they're interested in participation and that they have the tools to help them be purposeful and motivated on their own? How can we represent information in a way where students who potentially you have different languages or different ways of inputting and processing information can access that content so that then they can take these resources and use them to build their own knowledge? And how can we have kids express their understanding in a way that leverages their strengths and not just like highlights their deficits, so that they can tell us and like showcase what they know and move towards being, you know, strategic and goal oriented. So each of these 3 kind of buckets have different strategies that we can think about. And so if I kind of know what the goals are and I know what the barriers are, I can pick strategies within each of these 3 areas to address those particular barriers. So those 3 areas, the CAST website has guidelines, and each one of those you can go to the CAST website and see specific strategies for how to increase engagement, how to increase representation, and how to provide kind of action and expression. And so this is a really good tool in general that can be applied to any discipline. Essentially, there's been a lot of research on universal design for learning in different content areas with different populations, different ages. And so I find it to be a really good tool. What my lab has done is taken that and actually created examples related to computer science education. So this is just a Google Doc right now, and we're continuing to revise it. But within each one of these areas, we've put in some examples. So you can have access to this. So you'll have access, obviously, to the slides, and so you can click on that. And we've also created another one right now. We're actually working with PBS in terms of like, how do we think about this like in an informal setting or with younger learners or with television? And so we've got another document that's in process where we're looking at this more from like an early childhood perspective, as well as an informal education perspective as well. I'm checking my time. So this is an example of how do you take universal design for learning and understand barriers and create some projects. So one of the things we think about is a continuum from like kind of like taking that use, modify, create, and creating multiple entry points. So one is we create a project that students can play with and remix. And so these are projects that have already been constructed and they're intended to familiarize children with projects. Then what we do is we have the same project, but have it be buggy. And students can then debug that program that's not working, but they've already have access to a worked example. And then another one, which is like, it's like a Parsons problem, but we're working with younger kids. So we like calling it exploded code. It sounds more fun to them. And essentially all the blocks are there, kind of like a puzzle, and they need to reconstruct the code that's essentially deconstructed for them. Here's an example. And I think actually my grad student Alexis is on this call. She created this. And it's this dancing ballerina. And what she did is she created a play and remix, an exploded code, a buggy program, and then a spicy expansion. So I'm just going to click on a couple of these so that you can see. There we go. So this is a worked example. So it, you know, like looking inside, you can see that you know, there's the code for the ballerina and the code for the radio, and students can play with this and add to it and do what they want with it. They can also pick the same one, essentially have it be exploded, or here's the buggy version. Eventually, so clearly when you look inside, there's the ballerina's code, and there's something not quite right here. So the student would have to tinker with this and debug it. And then we always have this kind of expansion, right? So let's just say the student has worked through the project, and then like, can you make the ballerina move across the stage as she does her dance, or try adding something else to spice up the show? And so the idea here is that we're not saying, you know, Alexis, who's on, Alexis, you need to start with the exploded code, and somebody else, you need to start with a buggy program. We're providing all these options, and students have the opportunity to toggle between them as they learn. So the goal here is to help students kind of think through how to debug a program, how to create a program, how to add to a program. So our current study that we're currently designing, we want to get children to the point where they can be successful at creating and debugging on their own, but we recognize that we need to scaffold that process for learners. And so as we're teaching debugging strategies, we're also scaffolding those so that the cognitive load of learning how to debug and learning how to program isn't so intense that they're too frustrated and they kind of give up. So yay for Alexis. So I'm going to just share some of the studies. I already shared a couple of them in terms of our methodology. This is one study that we did with Broward County. We had a cohort of special education teachers, and we did professional development for the teachers. We gave them a lot of tech, and we met with them before COVID. You know, COVID hit, and then our professional development went fully online. And what we were hoping to do is get cohorts of special and general education teachers together, but we ended up getting a lot of special ed teachers and not a lot of gen ed teachers in here. So we just went with what we had. And not only did we teach computer science to the special education teachers, we also worked with them about, like, you know, assistive technology. How do you meet like individual education program goals with computer science? So for example, if students have goals related to self-regulation or communication or collaboration or literacy, how can we meet some of those goals with computer science? This was like fantastic. Our research questions were around the resources that teachers needed, as well as like features of professional development that would empower them. These are crates. So we essentially bought a lot of tech for teachers. It was a lot of fun. And so we got to play, we got to explore. And so, yeah, this was just the course management system. So essentially what we did in the professional development is that we talked about inclusion, we talked about individualization, we talked about accessibility features. So for example, they really liked the Sphero robot because there were so many different ways of students accessing it through coding, with their voice, through gesture. There were just a lot of access points. We talked a lot about what barriers they were encountering, and then strategies for overcoming them. For example, we have this tool called Puzzlets, where you were able to like have this board and put these tiles in the board and it moved the robot. But then we had some students who had low vision, and so we had to talk about, you know, putting Braille on those, for example, or how do we help students with collaboration during pair programming, like when the navigator didn't seem quite as engaged. And so we spent a lot of time just problem solving with the teachers. And then the teachers also created some artifacts to demonstrate what they did, and we talked about this. So this is a little video of, they were teaching about exterior and interior angles, and they were using the Dash robot. And so we would talk through some of these. I'm not going to show that because, but that was just kind of a sense of that study. And you can always look at that video later since you'll have access to it. Study 2 is a study where we looked at the relationship between instructional coaching and teaching, because we knew that in this particular district, and this is a collaboration with Cornell Tech, we knew that the teachers needed some support. And so we looked at how coaching in universal design for learning, how do you design these flexible environments, resulted in teachers' confidence in including students with disabilities, like how confident they weren't using universal design, how they could apply it. This ended up being a really messy study, also because of COVID, not just because of COVID, but we had 66 teachers. There were a combination here of regular classroom teachers, special education teachers, coaches. We have gifted and talented classrooms and English as a second language teachers as well. And then 4 coaches. And then we use, this is Meg Ray, who's kind of our coach extraordinaire, who led some of this effort in like helping with co-planning, observing, co-teaching, and providing professional development. And we used kind of a mixed methods approach with teacher surveys and focus groups with the coaches. I'm going to explain this because I hate slides like this, so I apologize in advance. But essentially, we had a repeated measures with like the teacher survey items that we focus on were like confidence in teaching computer science, confidence in teaching computer science to students with disabilities, whether they looked forward to teaching computer science, and whether they understood how to apply universal design for learning. So I'm going to tell you the messiness of it. So we were able to increase confidence in teaching CS and confidence in teaching computer science to students with disabilities. And we didn't move the needle in terms of looking forward to teaching CS, which remained high from beginning to end. These teachers were excited about teaching computer science. And we also absolutely did not move the needle in terms of the teacher's confidence in applying universal design for learning to CS. That remained low throughout the project. So this was an opportunity for us to think about how to support the coaches more in terms of understanding universal design for learning. The focus group really showed that the coaches had a difficult time applying that with teachers. The other thing that's interesting here is in a multiple linear regression, where we wanted to see what are the things that would contribute to teachers' confidence in including students with disabilities in computer science. The things that actually contributed to that were number of years having taught CS, confidence in teaching computer science in general, and understanding UDL in the context. So even though we weren't able to move the needle for those teachers who really could implement UDL, they were much more confident in including students with disabilities. And so this was a cue to us to really focus on universal design and continued support for coaches and teachers. And so our UDL for CS project now is developing those PD resources, because we know it's key, and we know that coaches and teachers just don't have a lot of access to what does this look like in the classroom. So again, I apologize for the messiness here. I just have a few more minutes, so I'm not going to go into more of this study, but I wanted to show you one last approach that we're doing. And this is, we had that video, the it's glitching video, right? So we're doing a lot of video analysis looking at students, and we're using log file data as well. So are students staying on track? What happens when they're struggling? What barriers are they encountering? What kind of discussions are they having? And so we've got this tool called the Collaborative Computing Observation Instrument that is super beta, but a demo is available on the lab website if you're interested in it. And then we're looking at a combination of that plus data analytics. So we're looking at sequential data mining and hidden Markov modeling, as well as cognitive interviews to understand the processes that students are engaged in. So we've got this kind of like whole system, PD, classroom implementation, and is it actually making a difference for students in the classroom? I'm going to show you kind of, let's see here, just, yeah. Like one kind of interesting finding from this. So these are different types of behaviors that students are engaged in. They see a lot of trial and error. Sometimes we see some systematic testing. Sometimes we see some kind of like partial testing and like students being able to like fully solve a problem and put a full solution. The thing I want you to focus on is this top left where you see trial and error. The probability of if a student is in trial and error, staying in trial and error is very, very high. And so what we try to focus on is how can we build some strategies to move students from trial and error to any level of systematic testing. And so those are the kind of things as we're looking at student behaviors and the impact of what these teachers are doing. That's one of the approaches that we're taking. So then kind of what's next for us is thinking about universal design for learning, but not in isolation. How does it fit with culturally responsive pedagogy? How does it fit with translanguaging and multilingual education? And so these constructs are distinct, but they should overlap, and we should have resources for teachers so that they're not learning about these particular approaches in isolation. They're able to think about if a whole child, right? This intersectional child who might have like multiple dimensions to themselves. And so I think this is really important for us as a community to do. It's important for me to learn more about as well. So this is kind of like a big piece of this. And so kind of the key takeaways that I'm hoping to leave you with is please include students with disabilities in your computer science education. Think about the kind of barriers that might be keeping students from participating. And if they are included, think about how to disaggregate the data to see whether they are being included and successful alongside their peers. From a UDL perspective, kind of think about what are the goals, what are the barriers, and then how you might think about those three UDL principles to design instruction that is more accessible. And then I think the last thing is to share successes. There's still so many barriers, there's still so many biases about who belongs, who doesn't belong, who can succeed, who can't succeed. And sometimes what we see is students who are not succeeding, that lack of success is often attributed to their disability rather than to a barrier in instruction or a lack of access. And so sharing the success stories of students with disabilities can start to shift the discourse around inclusion, around who belongs. And so that's kind of the spiel. I'm at 35 minutes and 49 seconds.
That's brilliant. Thank you very much. So in true seminar style, we can just say, do jazz hands, and thank you very much to Maya for a wonderful presentation. And we're just going to go now into some breakout groups for 15 minutes. There'll be somebody from Raspberry Pi Foundation in each of the breakout groups to support you, but the purpose of the group is to discuss with each other what you've heard and then come up with some good questions or comments for Maya. I'm sure there's lots of things, so see if you can together come up with some good questions and then nominate somebody in your group to bring those questions back to the whole group in about 15 minutes time. Welcome back, everybody. Are we all back, Diana?
Yes, We are, yep.
Yeah, all back. Great. So hopefully you had a really good conversation. I've just reshared the slide, Maya's slideshow in the chat there. And now we've got a few minutes for finding out what you talked about in your breakout groups and asking Maya any questions or making any comments. So who would like to start? Fred. Are we starting with Fred?
So from our group, here are my notes. First off, it's worth checking out this Coder Dojo because you're actually having mentoring with the students. And to me, that's very important. The next point was the appreciation for the work that went into that study and the high level of students who really need additional help. And again, I was talking to those with learning disabilities, if you will pardon my lack of proper terminology for the educational world. The question was, how do we take this forward and apply it? How do you unpack the learning process? In particular, if students are doing trial and error, how do you guide them onward? And a reference to the udlguidelines.cast.org to actually look at those. A question of whether there was a similar drop-off in interest as the students got older for those students without special education needs. And how do you learn that computers don't think like people? And my own aside to that is I once had an instructor who called the computer the idiocy amplifier. And I try to use that phrase when I'm teaching adults because anything where you make a slight mistake, it will amplify it. I don't know that that's appropriate with children. That's what we've got for my group. Over and out.
You were a busy group. That's a lot of questions. I'm not sure, Maya, did you you're going to tackle some of those? It'd be great.
Sure. So I guess I'll start with how to unpack the learning process. The way that I guess currently I'm thinking about this, which it's constantly shifting, I'll say, when it comes to I guess let me go back. So I kind of feel like, what is the role of the teacher here, right? So one of those is structuring a set of learning experiences where students can experience more and more complex computational problems, right? So typically what we've seen sometimes is, students are they're being exposed to some kind of computational concept, and then they're developing some projects, but we don't always do a very good job of structuring those experiences so students can encounter challenges that are more and more complex. So that's kind of one piece. What is that sequence? I think the other piece is how do we teach those metacognitive strategies so that, kids thinking about their own thinking is really important, right? So I think about Prim is a great example of that, right? So but really making that explicit for students, and then how do we at the same time structure and provide opportunities for students to self-regulate and experience frustration, know that frustration is important and is fine. There's nothing wrong with frustration, but how do you self-regulate through that? And then at the same time also, these have been kind of independent, cognitive things, but doing this in the context of how do we teach students to collaborate. So I feel like there's this whole ecosystem that as a teacher you need to think about in terms of the structure, the metacognition, the self-regulation, and where each child fits in the system itself. I'll answer just one more question too, because I know that there are other groups too. The drop-off in interest absolutely happens outside of students with disabilities too, and we need to think about that as a whole. I kind of feel like I contribute one piece of the puzzle, so there are other pieces that have to fit together too. And then my piece is just like, how do I unpack that and the inequity around students with disabilities? But I know that that data is absolutely the case broadly. And if you look at the intersection, like a student who happens to come from a high poverty home who has a disability, or who potentially also comes from another kind of subcategory of learners that's been, typically historically marginalized in computer science education, it gets even more complicated. So I kind of look at these as intersecting pieces that we need to unpack. I know that's not all the questions that you asked, but that's at least a couple of them.
Oh, that's great. And we can always come back to some of those points. And Yotta, I think you also had I can't see Yotta now, had your hand up to ask a question from your group.
Yes, Maya, big thank you from our group for your inspiring presentation. We loved it, and we spent a lot of time, as other groups are saying, about discussing. So we have a lot of positive feedback, and we are very interested in a couple of things. I will share the questions, and my group can help me if the focus isn't right. So we were fascinated by your slide on the jagged representation of knowledge. And part of it is how do we construct it? But then once we know, what do we do with that knowledge? And how does this fit into planning activities? What is the focus? Is the focus on things that we're not doing well or things that we're doing well? How does it fit in an inclusive design? That's one question. And as an extension of that is, so all this knowledge, when we create these activities, how do we do it in an inclusive way and deal with the complexity of that knowledge, and including maybe the additional profile that a disability may have or bring into the equation? And then the other, so that was question 1 and 3 group. And then the question, or one and 2. And then the third question is, again, in terms of your future plans, you have got UDL in a cycle with the culturally responsive pedagogies. And how do you see all of them working together? Do they work in parallel? Do you think they're cumulative? Should one precede the other one? So we've been in your views.
Oh, great questions, really complex ones too. So I'll try to answer them. So the jagged learning profile, I use that as more of a reminder of the reason why we need to create flexible instructional materials. I don't mean to suggest that we have to unpack each individual learner's profile and then create instruction for them. But what I do think is that it provides the rationale for providing multiple means of representing. So having different ways to access the content and for kids to engage in content, knowing that we can't possibly understand every learner's profile. And so for me, that's the rationale. The way I look at it is that from a universal design for learning, it's about how do I design tools and curriculum and lesson plans for a classroom full of kids with jagged learning profiles. And then on top of that, there are particular students who have a specific need that we have to address on top of that. So I can create the most flexible, beautiful instructional lesson plan, but I'm still going to have some learners who are going to need something on top of that, right? There are specific accommodations that they need. I'll have to have fewer of those if I design instruction in a more flexible way, but I can't, like, for example, I have a brother with significant needs, and he uses a communication device because he doesn't have verbal language. And he also has some like mobility issues. And so he still would need to be able to access the content. So I would layer that individualization on top of that. So that's kind of how I look. So I think that kind of answers your questions 1 and 2 in a way. Not fully, because it's pretty complex, but what I think about, like generally, what are the barriers that my students will have? And then I think about those UDL checkpoints, like in that table, about like, how do I provide options for my students? And I guess one of the things to remember is like a lot of it, especially, I come from a special education background. There's a lot of like, the role of the teacher is really being responsible for the students' learning. But what I really want to shift it is if I can provide the tools for the students, and it empowers them to be able to pick the things that they can use that allow them to learn. So sometimes with students, they'll pick, like they'll only do one thing, and it's like, okay, this is hard, so I don't want to do that. So it's still a matter of encouraging students to do things that are difficult for them, but then having those tools and resources so that they can be as independent as they possibly can. So that's kind of a piece of it. Your third question is about the intersection of culturally responsive pedagogy, UDL, bilingual, multilingual education. They're distinct, and they have a lot of kind of nuance on their own. So I think it's really important to understand how to design instruction that's personally relevant and culturally responsive. I don't feel like one supersedes the other. I also feel like they do work in tandem. So right now, CAST has a working group that's trying to do some of that intersectional work. And my thinking on it is, how does this apply in this context of computer science education? So I feel like we have a lot of work in terms of how to do that. So for example, I'm getting some folks together who are doing bilingual education. So Sarah Vogel and her group out of NYU. We've got some folks that are real experts in computational thinking. So we applied for a grant to see if we can do some of this work. I wish that we had the tools and I would have the answers to your questions now. Other than that, I know that those are the right questions and that we need to, like, as a community, think about how these things intersect. And so I feel like that's the direction I want to go in. And hopefully like a year from now, if you talk to me, I would have a better answer, other than like, yes, they're important. I don't think one supersedes the other. And that we need to do the heavy lifting for teachers rather than say, oh, you need to teach in this way. Like, what does it look like? What are examples? I think that's really important.
Any other points that came up from any other groups?
I have a question, Sue, if that's okay.
Yes, yes.
It leads on from one of the ones, sort of from one of the other ones, where Maya, where you talked about concentrating on maybe on metacognition or self-regulation and things like that. I was really interested because in part of your talk you said that a lot of your teachers involved had that sort of understanding. They had learnt those skills as special educators, but the problem was actually doing it in computing. So I was wondering if you could talk a little bit more about the sort of the interaction of the two, and whether do those teachers need to be focusing on the metacognition and the collaboration and those other skills you talked about, or is it something to do with that interaction between those skills and computing that's the most important?
Yeah, that's a really good question. So I think that so there are two kind of classifications of teachers. Actually, maybe there's more than two. There are three maybe that we'll talk about. There are the teachers who know computer science, like they've taught computer science for a while and they haven't thought about inclusive practices, and we have to really teach them about what is UDL, what does metacognition look like. I mean, they know about what metacognition is, but like, how do I scaffold that? How do I make that explicit to learners? We have teachers who work with students who struggle academically, who really understand universal design for learning, and they understand kind of doing this work in the context of a science classroom or a math classroom, and then they are new to computer science. And then we have kind of the larger category of kids, and they're the twice new. They're new to computer science, and they're new to thinking about this context in the, they may have heard of UDL, but like applying it to CS education is a brand new thing for them. And so we approach it different depending on the teachers themselves, if that makes sense. But I think a lot of it is thinking about, is simplifying the process in terms of how do I think about my own thinking? And so like debugging, like there's thinking about your own thinking, but then there's like kind of very specifics to debug, like there's the technical piece of it as well, right? That we need to make sure that students know. And so trying to unpack that for teachers is really important. So I'm going to just share my screen and like, just because this might be helpful to you. So in one of the projects in the LTech project, we've developed some learning trajectories around computer science and computational thinking. Let me just get to where I want to go. And maybe, oh, that's not where I want to go. Okay, I'm going to share my screen. So kind of, you see my screen here? So we've got these different learning trajectories. I'm going to go to debugging because I think from a metacognitive perspective, this is probably the one that, let's see if I can make this bigger. Nope. Conditional, that's good. Okay. So what we did is we designed these learning trajectories based on kind of the implicit things that we were seeing in the literature. We're revising it now that we're testing these out. So these little gray boxes here, like outcomes, can be used to decide whether or not there are errors, or iterative refinement can fix errors. We can teach children how to do that. And so, and if a student can demonstrate that they understand this concept, they can move towards like a more complex understanding of debugging. The gray ones are things that can be taught and demonstrated in an unplugged way, right? So you can, errors can play a valuable role in solving problems, is not something that you have to do in a computational environment. But Haley, when you're saying like what's specific to computer science, these ones that are not grayed out are ones that we feel like are specific to computer science. So errors can be caused by missing as opposed to incorrect information with instruction, is something that's very specific. So this is where we talk about the metacognition, but in the context of computer science. There are some things that are not specific to like just problem solving, and then there are things that are very specific to computer science as well. Does that answer your question a little bit?
Yes, thank you.
I feel like we're just scratching like the surface. Like we're just so early in our understanding of this that, you know, as we're pretty new in doing this, especially with youngsters.
Yeah, no, it's absolutely amazing work though. Thank you so much.
Oh, there's another raised hand. Daryl, would you like to ask your question?
Yeah, when I've been as a teacher, when I was using something like Scratch in the classroom, I actually really relied more on the peer-to-peer interactions. Like I would target like the advanced users. They became like my wave of students. And so how do we, I feel like what we're addressing is the teacher, that like training of the teachers, but how do we approach like a UDL framework where we help our students that are going to be like our peer helpers, like using a tool like Scratch? How do we help them begin to interact with the students that may need that scaffolding?
Yeah, great question again, because there's a power issue that happens, right? So we don't want to create a situation where we have like the smart kids and the kids who always need help too. So part of what we do, and you probably did this too, there are expectations for how you give help in a more empowering way versus one where you're like, okay, let me just do this for you. And so we just like with the metacognitive strategies that we explicitly teach to students, we explicitly teach how to collaborate for students with each other. So one of the things that we know is the way that you ask for help can really make a difference in how you learn and understand. So there's a whole bunch of literature around adaptive help seeking. So like if I just go, this stinks, and then somebody comes and does the work for me, then that's one way. But another way is to say, I'm trying to get the rain sounds, right, to sound like rain. And I've tried, X, Y, and Z, and it didn't work. That's another way. So I'm going to put a link here to a collaboration strategy that we use. We call it the collaborative discussion framework. And essentially what we do is we teach the entire class this process. And you've heard probably a little bit of this in the video. So the peer is supposed to ask, what are you trying to do? And then what have you tried already? It really kind of puts the onus on the student to articulate what they're trying to do. What else do you think you can try? What would happen if? So these kinds of conversations shifted so that it's not about the peer doing the work for the student who needs help. It's about having the discussion that could hopefully help the student understand what the problem is. So we did a study with this particular collaborative framework, and it actually bombed, to be honest, because rather than using some of those metacognitive strategies that we worked so hard to teach, students immediately went to their peers. And so kind of our next version of this is having a tool where they go through kind of self-reflection first before going to collaboration. And I think I probably could have foreseen that, but you know, that's how these studies go. But I think that it's really important, Daryl, to think about the power dynamics. So I think that's a really good question that you asked, because you want to make sure that definitely leverage the expertise in the classroom, but do it in a way that kind of empowers the student who needs help.
This is Fred. Just one insight I've found in teaching new languages to, in my case, college students or working professionals. It was always code a little, test a little. Never code more than 5 lines before you test. And that worked pretty well.
Yeah, that's definitely something we do too, because what we see is kids will program and then they'll test it and then it doesn't work. And then it's like, they'll get rid of everything and then they'll do something again. So we've got this process of like, does any part of my code work, right? Or like build and test and build and test. And so this slide that we had that showed kind of systematic testing, there are different strategies like that we make sure that we unpack, because you're right, it's oftentimes they just work and then they're like, yeah, this doesn't work. It's like, well, now what?
We're coming to the end. I think, I don't know if as chair, I'm allowed to ask the last question. My question is around, you talked about a lot about programming and computational thinking, Maya, but do you look at things that computer science areas that aren't programming? You know, obviously, you know, we learn about networks and hardware and computer architecture and data and all these other things. And we've been trying to do learning graphs for those topics as well. I wondered if you got any insights on those.
Yeah, I wish I did. I feel like this is one of those like my focus is so narrow, and I think that we need to have the conversation about computer science education being brought more than, you know, programs and algorithms. You know, the CS framework is where I go for that, but I'd say that it's outside my expertise because I just don't do work in that area as much. So.
I do. So let me interject 2 things and I'll get off the line. Very few people can document the problem accurately. In all my professional working career, I've encountered 2 people out of perhaps 500 that I've worked with directly who could do that. And it leads to my axiom, which is, if you can describe the problem, any idiot can code it.
Yep, algorithm design and yeah, brilliant.
Querying the user about what they really want.
Yeah.
You know, because frankly, the user doesn't know what they want. They can't express it. And for all of you who are not in the industry, please Google a video clip called 7 Red Lines, Lines. It is quite an education for the profession of the professionals in the industry.
Good, great. You might want to put the link in the chat, Fred.
Right now, I don't have a link, but I can tell you what to Google for.
That's right. That's great. I'm conscious of the time. I'm sure we could discuss. There are other questions that we don't have time for. I don't want you all to be late for your next thing. So if we'd just like to give Maya another big jazz hands and clap, I can clap because I've got my mute off. So thank you very much for coming all the way over to Cambridge. It's we're lovely that we're online and we can share in all this wisdom wherever we are. And it gives me another minute just to say that we have other events coming up. And the next seminar, which is in a fortnight, is something that Maya's been touching on during a seminar about students with low vision, with visual disabilities. And so in a fortnight, we have Cecily Morrison coming to talk to about physical programming, like programming with an actual tool that you can hold. For visually disabled and visually impaired children, and that should be really exciting. I think that's on May the 4th, if I get the date right. And before then, next week we have a special event which is on a Monday and not a Tuesday, but at the same time, still at this 5 o'clock GMT, 9 a.m. Pacific time, which is our gender balance panel, when we're looking at the affordances of formal versus non-formal learning, and which of these, how these contribute to gender balance and what their role is, etc. Yotta, who you've heard from earlier, will be chairing that session, so we're looking forward to that as well. So thank you very much. We'll be sharing the video of this seminar shortly, in about a week, and a blog post about the seminar. Maya's already shared her slides, but we'll put those up in a format for sharing too. So, and if you want to tweet, you can carry on the conversation. And now you can all unmute and say thank you to Maya personally. And I'll see you all next week, in fact.